Okay, so hi everyone. Today I'd like to give you a quick introduction and a demonstration about the new feature I developed for Kubeless, the serverless native framework on Kubernetes developed by Vietnamese engineer. And the new feature today introduces the auto scaling with custom metric, and it applies on the Kubernetes version 1.7. So you all might know that Kubernetes support auto scaling with the SPA object, the horizontal box autoscaler object, but by default it only supports for CPU and memory. But in many situations, we would like to scale our application based on other kind of metric. For example, the number of incoming requests. So in order to do that, I developed this feature and I embedded in Kubeless in order to scale the function based on the custom metric. Okay, um, so this demo I running Kubernetes on by kubeadm using a Docker in Docker feature, and this script developed by Mirantis fork, and you can just clone this repo and you run it up. So before the demo, I'd like to give you some explanation how it works. So basically, you might know, auto scaling need the monitoring system, and by default is your Hipster, the built-in monitoring service. But in order to have the custom metric, I use Prometheus, and but then you need a way to let the SPA controller can contact to Prometheus system in order to fed the metric. And in order to do that, the Kubernetes version 1.7 introduced a new concept. It's called aggregator layer. So aggregator layer is the concept to either the way to let you register the custom, or I call additional API server. So you already know that Kubernetes have the built-in API server, but now you can register the new one to the cluster. So if you have the custom API server and you have the Prometheus and you have the function or application export the metric to Prometheus, and then you can let the API server fed the metric from Prometheus and then pass it to the API SPA, horizontal box autoscaler SPA controller, and then that is it should work. Okay, but in order to enable and configure the aggregator layer and configure the SPA controller, you need a couple of configuration in Kube API server and couple of configuration in Kube controller manager. So I wrote it here, the tutorial, and I list out the specific flag in order to be set to enable everything I described before. And also you need to register or enable the auto scaling /v2 alpha 1 API group in order to declare the SPA with the custom metric. And you do this with the runtime-config flag in Kube API server. So I do everything in my cluster. I have the cluster with one master and two minion, and I already enable and configure the necessary parameter, and I can check it here. You can see Kube system. Let's say I need to check the configuration of Kube API server, and you see here I enable the API slot all set to true, and I check the controller manager, and I see here, you see here I set this flag set to true. This flag means you configure the SPI controller to use REST client in order to contact to the API server, not contact to the hipster. Okay. So in order to check if you have the auto scaling v2 alpha 1 enabled, you see it here. So you have the setting properly, and now the next step, you need to deploy Prometheus system, and you also need to deploy your custom API server and register it to the aggregator layer. So I reuse the Prometheus operator software developed by Kubeless. And so basically you need to deploy the Prometheus operator and the Prometheus instance. The whole manifest I provide already in Kubeless repository under the manifest auto scaling folder. You can check it later. So you deploy this one, and you deploy the custom metric API server, and after that, the API server will register to aggregator layer automatically, and then you have this API group enabled. So let's say I have everything configured and enabled. You can see here I have Prometheus operator and Prometheus instance, and I deploy the custom API server at the custom metric namespace. You see it here. And in order to check if I have the new API group enabled, I use kubes control API version command version, and then you see the new API group here. Okay, so we are good. The next step, I will deploy my function using Kubeless, and then I auto scale my function with the custom metric. I pick it up here in the function call. The function call metric means the number of incoming requests to the function. I have my Kubeless system running in. Oh, I don't have it. Okay, I will deploy it. Create that Kubeless RBAC, view RBAC, because we are in 1.7. I use the 1.0. It's our first beta release of Kubeless, and I have it here, and you can check it. See the controller running together with Zookeeper and Kafka. So I will deploy my function. I think I do it before. I did it before. Okay, I will check it. We provide several sample function in a sample folder. I will just deploy very sample. I will cd to a sample. I deploy it, and I see if I have the function here. Okay, I have the function object is the third-party resource object, and I have the function pod running. And in order to check if the function running properly, I will just use Kubeless function called getPython is the function name, and you see it return hello world. So it's a very dummy function, but it just shows you it's running. Okay, so now I have the Kubeless Auto Scale command in order to create the auto scale rule for the function, and I have the subcommand create here. You will see that I have a little bit. I will create. I point out the function name, the get Python. The minimum replica is 1. The maximum is 10. What's else? The metric. Keep in mind that currently Kubeless only support 2 metrics. The first one default is CPU, and the second one I call it QPS, stand for query per second, or you have another meaning is the number of incoming requests per second. And I will do is I will use this QPS, and I figure out the value. The values is the integer number. So let's say I figure out, I set value equal 5. That means you need to make sure that auto scaling feature work with the function to shove 5 query per second. Okay, and now you will see auto scale ls or list, and you see here the mean and the max and the metric. The metric I call it, we call it function call, and the function call is the built-in metric expo from the function runtime, and it's passed to Prometheus under the select metric URL. And by theory, the function call metric will be passed to Prometheus instance, and then the custom API server we deployed before will fetch that metric and pass it to API controller. So with the Kubeless Auto Scale create, is under the hood it create SPI object. And you see here we have a new SPI object with the get Python name. Point to the get Python function, only one replica. The target we need to wait a little bit. I think SPI. I will try to call the function. I think I have the I have it here. It's say hello world. I call it another one more time, 3 times. Maybe I have a problem with. I will check Prometheus. Okay, so I see that Prometheus can look into the get Python function here, and the state is up. Maybe I've had a problem with SPI. I will just check it. Describe SPI. Is I feel unable to get matrix function call. I'm not really sure. Okay, it takes a little bit of time, you know. When I developed the auto scale feature, I figured out that the SPI controller loop is really long. I mean, it reacts to the chain in cluster very slowly. But at least it worked. Okay, so now the thing I would do is I increase the load to the function by implement a loop. What that? Get Python AT done. I call to the function 1000 times, and it say, oh no, hold on, no, done. That is done. Okay, so I call to the function 1000 times, and we can see the load to the function will be increased. It reacts a little bit slow, but you will see it. The only thing we need to do now is just waiting for the SPI changing. Okay, we keep calling the function, and it should increase the number of incoming requests here, and then by the end you can see the function port will be increased. Now you only have one replica of get Python. Okay, you see some number up here. I will just put it here. I use kube control proxy to open the port and call the function with the localhost 8081. Okay, it's a little bit higher here, and then you see the get Python is scale. So now you have maybe 4 instance of get Python. Okay, and if we wait more time, then you can see, because we doesn't call we don't call to the function anymore, then the SPI metric will be scaled down. You see here the replica is 4, but if we wait a little bit, it will down and down, and then you have a number of get Python part will be scaled down. So we wait a little bit. Okay, so it's go down to 0, and then it will automatically terminate some get Python part. In this demo, I just showed you the quick tutorial step by step to configure your cluster and use Kubeless to deploy your function, and Kubeless Auto Scale command to setting the auto scale rule to your function based on the custom metric, the incoming request per second. You can definitely use the default metric is CPU if you want. And now, right now, the SPI controller reacts a little bit slow. So the next step would be I will try to figure out how to set the SPI controller properly to make it react faster. Okay, it still have 4 instance. I think it should be maybe 1 more minute. So the next step would be optimize the SPI controller, and the second step would be support more metric like the memory consumption or something like that, or whatever. But the whole infrastructure is the same. You need to deploy Prometheus, and you need to deploy the custom API server, and you need to connect all piece of software you have in order to make the smooth flow from the function runtime to Prometheus to custom API server to SPI controller. That is. I don't want to end the demo right now. I need to wait. I want to wait in order to see the function being scaled down automatically. So 1 more minute. It should be terminating. Okay, I give up. And yeah, so now the Kubeless Auto Scaling feature is already commit to the Kubeless repo. You can check it out on github.com/kubeless. And PI, welcome. Thank you for watching. See ya.